What we're doing today, we are actually doing a lab today. We're going to be doing a lab calculating and measuring the heat of neutralization. So write this down, copy this down. We're going to heat of neutralization lab. The heat of neutralization lab. Now, I'm going to ask you guys this. When you are neutralizing an acid and a base, okay, just to speed things up, neutralization is between an acid and a base. What do you need to do to neutralize them? What do you need to do to the acid and base so that it becomes neutralized? Say again? You mix them together, but mix them together in terms of, you mix them together, but what? The same amount. It is one thing that has to be the same amount or the same strength. Has to be the same amount or the same strength. Maybe I'll zoom in a little bit so you guys can see it a little bit easier. So in this case, what we're having today is you're going to have HCl, hydrochloric acid. You're going to mix it with NaOH. NaOH, not NO. Wow. NaOH, sodium hydroxide, and then you're going to get water and salt, which is NaCl. Okay? Now, because it is the same amount or same strength, there. What is the ratio between the acid HCl and NaOH? Just a review to a little bit of things that you've learned last year or just before Christmas. What's the ratio between these two?
1 to 1.
It's a 1 mole to 1 mole ratio, right? Now, what you're going to be using today, you're going to be using the acid that we have on the back is 1 molar HCl. What is 1 molar HCl? What's another way to show 1 molar HCl? What is 1 molar HCl? 1 big M is the same thing as, that was on your test. Say again? There's a molar concentration, but what does it stand for? So what does it mean then in this case? 1 molar concentration equals what? What's the unit? You're right, 1 mole per 1 mole per liter. Good. 1 mole per liter. Okay. Now, for today's experiment, you're only going to use 100 milliliter or 100 centimeter cube. So if you're going to use only 100 milliliter, how many moles are you going to get?
0.1.
0.1. Okay. Number of moles equals concentration times volume. Just a reminder. Concentration is 1 mole per liter. You're using, now 100 milliliter is the same thing as 0.1 liter. So in this case, 0.1 liter. So this cancels out. So it is 0.1 mole. Okay? Good so far? Questions? Now this is 0.1 mole of HCl that you're going to have in your reaction mixture. Since it is a 1 mole to 1 mole ratio between the HCl and the NaOH, what it means is that you also will need 0.1 mole of NaOH. Do you guys follow so far? Because it's a 1-to-1 reaction. So if you only have 0.1 mole of HCl, you also need 0.1 mole of NaOH. So if you want to have 0.1 mole of NaOH, how do you find the mass of the NaOH that you need? How do you do that? Mass equals, you guys, it's a level 2, a level 3 question, guys.
Molar mass.
Molar mass, molar mass, mm, times
Number of moles.
number of moles, n, okay? So, in this case, take out your periodic table. Take out your periodic table. Wow, I have a big pile of them. Take out your periodic table. Did you get one from last? Okay, make sure you get one. Take out your periodic table, and the rest of you, I want you to start calculating that. Okay. Hey guys, what's the molar mass of sodium hydroxide? Huh? 40. Good. So it's 40. You want 0.1 mole. So in this case, you're going to use really 4 grams of this stuff. Okay? Now, since I'm recording, so what I'm going to do is I'm going to draw some diagrams here, and I'm going to talk about the safety while I'm video, and then later on I'm going to point out over there the little precise stuff. So can you guys all look up here, please? So what you're just going to do is, over there, you're going to get, on the back of the room, there are styrofoam cups. So there are styrofoam cups, and what I'm going to ask you guys to do is to measure out, first of all, measure out 100 ml of HCl. You pour it in there. Now, because you're going to try to find the rate, trying to find the heat that's generated by neutralizing. So, what are you going to do? what are the temperatures you will need?
Before and after.
Before and after. So you will, on the back side over there, there is also a thermometer. You're going to put a thermometer in there. You're going to measure initial. Now, rather than saying before and after temperature, it sounds a lot better if you say initial and final temperature. Because right now the acid is in room temperature, whatever it is. After you throw the base in, it's going to heat up. But if you don't measure the temperature before, you don't know how much it went up by, right? So you need to measure the temperature before. After that, you're going to use the electronic scale over there, and you're going to measure out 4 grams of NaOH. You're going to measure that out, you put it in there, and then you will record the final temperature, or the highest temperature. Okay? And that's it. It's very straightforward and simple lab. Now, in terms of safety, a few things. First of all, you're dealing with an acid, HCl. It is a 1 molar acid. It's not the strongest. So if you want to, you may wear goggles. Okay? It's not the strongest. Okay? You can wear goggles if you need, whereas the chances of this acid spraying to someone's eye, we're not using pipette, is low. Now, one thing I want you guys to be very careful about is this. We are dealing with NaOH as a solid. Industrially, this NaOH, sodium hydroxide, is also known as lye, L-Y-E. Okay? It is a industry. People use it to clean things and dissolve. People use it to clean things. And back in the days, this is the chemical they used to make soap with when they mix with animal fats. It is a very strong substance. It is highly corrosive. If your hands are wet and then you touch that stuff, it will give you a chemical burn. Or if your hand have a small cut and it gets on your hand, it could get nasty. So we do have gloves in the back. You can wear them if you want. Or if that stuff get on your hand, but your hand is safe, but your hand is dry, just quickly rinse it off. Okay? Under running water. Last but not least, please do not let the thermometer rest in the styrofoam cup like this. The thermometer is a long thermometer. Even with the acid in there, sitting in there, it's not enough weight to keep it stable. If you just let the thermometer sit resting in the styrofoam cup and leave it unattended, sometimes it can tip over and pour. Okay? So make sure you don't leave the cup with the thermometer lying unattended. After you record the temperature, take it out. Okay? Any questions? Okay.